So in this class I am going to explain sums from geometrical optics. All sums are taken from NCERT for this session. Okay, you can keep your NCERT book open and do practice with me, or if you can see my screen then also it's okay. I hope you are able to see my screen also. The first one, small bulb is placed, probably this is some number 5 or 6 from NCERT. Small bulb is placed at the bottom of a tank containing water to a depth 80 cm. What is the area of the surface of water through which light from the bulb can emerge out? A refractive index of water given to be 1.33. So this is water surface, bulb, from the bulb light will enter the air after penetrating the medium of separation. But there is a limit. I mean, after that, the emerging light ray, this I have explained in theory portion like fish's eye view. So after, beyond certain area, the light will remain in the first medium only. If you send any ray this manner, if you take rays beyond this, those rays will be totally internally reflected. So the rays coming from the source will make a circular region. Okay, so this circular region radius you can write, we have done it in class. In fact, this is R, this one H, this is the critical angle, so this is also IC. In this diagram, what do you get? R by H equal to tan IC, and sin IC you know 1 by mu. From here you have to calculate the area of this region, area of the circular region. This area of circular region A equal to pi r square. The value of r you get from here, you substitute. What is the value of r here? If you cross multiply, H tan IC. So this will be pi into H square sin square IC by cos square IC. Okay, so this is going to be pi H square sin square IC, you write sin IC 1 by mu, and cos square IC 1 minus by mu whole square. So finally A going to be pi H square by mu square minus 1. Okay, so I'll remind you how to get it. Formula also if required I'll derive it again, but finally by putting values you have to get. Okay, I'm doing it. This one, depth is 80 cm, put it there, pi into 80 square, mu is what? 1.33. You can make it 4 by 3 also, no problem. And then I am going to calculate this. Pi into 80 square, 36400, 1.33 square minus 1 into pi. So it's coming 2.6 10 to the power 4 centimeter square, 2.6 meter square. Area of the region through which the light will come out is given by 2.6. Area of surface of water through which light from the bulb can emerge is given by this. That is 2.6 10 to the power 4 meter square, centimeter square, or 2.6 meter square. Clear? Now let us go for next problem. All sums from NCERT. So you can start, you can do before I complete the sum here. Prism is made of glass of unknown diffractive index. Parallel beam of light incident on the face of the prism. Angle of minimum deviation is given 40 degree. Then 5. So this is a direct relation based problem, isn't it? Unless otherwise stated, we will take the base as triangular only. So light ray entering, just remind you the concept, then diffracted, then again it is finally refracted from this surface. Ray of light going this way. Then mu will be equal to sin A plus del m by 2 by sin A by 2. This is the value of mu. You have to find the value of mu. It is given angle of minimum deviation delta m is 40 degree. So use this relation directly because angle of prism also given, that is 60 degree. So mu will be what? Sin 60 degree plus 40 divided by 2 by 60 degree by 2. So mu equal to sin 50 degree by sin 30 degree. Let me do it by using my calculator. Sin 50 value I don't remember. Sin 50 going point and this one 1 by 2. So just multiply, it is coming 1.532. Finished? Now there is another part of this problem. If the prism is placed in water, predict the new angle of minimum deviation of a parallel beam of light. Any beam of light, just I did not take parallel to one face or like that. I have just taken a parallel beam. Parallel beam was being incident in this manner. They are all parallel. They are incident, and in that case deviation, the way I explained, it will be the same. Here, if you surround it by another medium, then angle of minimum deviation obviously going to be changed. Why? Because the value of mu is changing, no? And that we have to calculate. as mu dash equal to sin A plus delta m dash by 2 sin A by 2, then mu dash is changed. Mu dash initially actually mu g. No, mu g no, just glass prism mu g. But this time it will be mu dash will be what? Mu g by mu liquid. If it is water, mu g by mu w. So just put there the value of mu g, that is 1.5, you put directly 1.5, 1.33, 60 degree plus this divided by sin 30 degree. Clear? So 1.55 by this will go up, (30 plus delta m dash by 2). Again I need my calculator here. Okay, this we write 1.55 by 30 degree plus delta m dash by 2. Okay, and now if you divide and then take sin inverse, that will be the right thing. Therefore 30 degree plus delta m dash by 2 will be sin inverse, that 1.5 by 2.66. This is going to be 0.5759 approx. And by using calculator again, let us find this angle. It is coming 35 degree 10 minutes. So delta m dash by 2 equal to 5 degree 10 minutes. Now cross multiply. Delta m dash new angle, this multiplied by 2. 10 degree 20 minutes. Hope you have understood. It was not a difficult sum, simple sum in fact, isn't it? In board exam, if it is asked, or in competitive also, they can convert this into MCQ. Then sin inverse, that value will be given. You will get some data on it. Don't worry. Okay. Now let us go for the next problem. It's okay. You have understood? Anybody has any problem? Or it's okay? Not a difficult sum. Just ray optic means ray diagram. Ray diagram if in your mind, and then formula, then it will do very first. Let us do next one. I am going sequentially, but I did not take all sums from NCERT. Okay, all sums we cannot do here. Double convex lenses are to be manufactured from a glass of refractive index this, with both faces of the same radius of curvature. What is the simple question? Radius of curvature required if the focal length to be this. Double convex. What expected from you for this kind of sum? You all know what is Lensmaker's formula. 1 by f equal to mu minus 1, 1 by r1 minus 1 by r2. Now you know this is made of two surfaces. For AP1B, center of curvature lies here. For AP2B, and it is a thin lens. So diameter not going to irritate you. But in some HC Verma or Europe, the diameter is a problem. That I will discuss not today. Today only textbook sums. But once you are confident here, maybe these sums are very easy, you think. But once you can do all sums from here, I think you can start from any book in this world. You can start. I did not say that doing NCERT, every sum from other books you will be like HC Verma, Resnick or Resnick Halliday Crane or Iroda will be able to solve. But if you can do something on your own, then this confidence will pay you. Okay? So, okay, for this sum, what to do here? This one for AP1 with this radius of curvature, this R1 positive, and for this R2 is negative. For a double convex lens, that R1 should be equal to R2. You agree or not? Apart from sign convention, R1 should be equal to R2. So this implies 1 by F. This is 1 by R minus 1 by minus R. And when you are getting ready for board or other exams, the new edition book you might not have got, all of you. Old one also will work, but go to CBSE or NCERT website. That particular chapter you see mark in your book. For board or entrance, initially do those sums. It is very easy, I am telling you. You can start yourself also. So the problem is to find the radius of curvature. Find R. R will be what? Just put the values here. Focal length will be 20. Mu is 1.55 minus 1. Just do this calculation. 40 into 0.55. I think it's coming 22.0. Check once. Calculator, let's see what it says. Same thing. It's coming 22 centimeter. It's alright. Clear? Now go for this sum, which understanding is very important. And ray diagram. If you do mistake over there, some maybe for board, for any entrance, a ray diagram, if it is not playing in your mind, then you won't get success here. Geometrical optics ray diagram is very important. So for this sum, beam of light converges at a point P. Now let a lens be placed in the path of convergent beam 12 cm from P, where it is supposed to converge. From there at a distance 12 cm, you are keeping a lens. At what point does the beam converge if the lens is a convex lens? So what is happening in the beginning? Try to understand. Rays are coming. And it is given that they get focused. They meet here. Okay? Many rays may be there, I am taking just 3. This is the point P where they are meeting. A lens is placed in the path of convergent beam. We are keeping a lens, and first time I am taking the convex lens. A convex lens is placed on the path. Then what will happen? These rays, after passing through the lens, now will converge before. Agree or not? They will converge at some other point, say P dashed. They are meeting at P, now they will meet at P dashed. Why? Because this is convex lens, that's why. For concave, what will happen? Then, for concave lens, what will happen? For a concave lens, this will diverge. If this is convex lens, let us see the problem first. This one 12 centimeter. Okay. And this convex lens has focal length f equal to 20 centimeter. Okay. So this P dash, actually one can think that it is the image found by the lens whose object is at P. So now for this lens, for the lens, P is the object and P dash is the image. So therefore, by using this solution 1 by V, by using this, V is what? V. Just to find that V only. This U is positive because it is found on the other side. So this U is 12 centimeter and focal length of convex lens is always positive. It will never be negative, or it will be negative. Can a convex lens behave like a diverging one? It's a question. Can a converging lens behave like a diverging one, or a opposite diverging one behave like a converging one? Yes, they can do if their refractive index smaller than the surrounding. In that case, convex will diverge, concave will converge. I mean, rays through concave will converge. Got it? Now this is 1 by F. F is what? F is given 20 and it is positive. So 1 by V is 1 by 12, 1 by 20. LCM is 60 over there, 5 plus 3. So V going to be what? 60 by 8. Am I correct? It's alright. So this ray, rays supposed to meet at the point P, now they will meet at the point P dash. Draw a clear diagram, then everything will be clear. What will happen for diverging lens? You can draw the diagram before I do it here. For converging lens we got. For diverging, if you don't draw a diagram, it is not only true that you will lose board mark. It is also true that if it plays in your mind, that is different issue. You will get wrong answer otherwise. So for concave, what is happening? First, to show by diagram, rays were supposed to meet at this point. We are keeping a diverging lens on the path. Put the ray direction. Direction given. Here what we are doing? We are just keeping a lens No, this is not converging, this is going to be diverging one. Yeah, what a diverging lens will do? Diverging lens will diverge rays. Now they will be going like this, they will be meeting at some other point, P double dashed. Okay, it is not true that yellow one becomes red after passing through that. Okay, so let me correct that Yeah. So this time ahead of the lens. So for concave lens, what's the focal length given? Let me check. A concave lens of focal length 16. So for this concave lens, f equal to what? Minus 16. Concave lens don't have focal length positive so long it is stated that its refractive index is smaller than that of the surrounding. So this part going to be what? PP dashed. PP dashed. This is 12 given. Sorry, not PP dashed. This object distance P from the lens is 12. This you have to find. They are supposed to meet at P. Now they are diverged. They are meeting at P dash. This distance you have to find. So F minus 16 and U equal to what? Plus 12, not minus. Right side, anything will be plus. Then 1 by V, it is lens. 1 by V minus 1 by U equal to 1 by F. So you just put V we have to find, U is positive here also, 12, and this is minus 1 by 16. So 1 by V will be so 1 by V, you take LCM, 12 and 16. So V is going to be 48 centimeter, isn't it? Check once. Hope you have understood. Any other part given in the question? No, this is done. This was the problem we did. Now let us go for next problem. An object of size 3 cm is placed 14 cm in front of concave lens of focal length 21 cm. Describe the image produced by the lens. What happens if the object is moved further away from the lens? What image will be there? It is a concave lens. Do by calculation, get it by calculation. Concave lens is there. Object is kept here. Object of size given. AB is the object. Size given, you know how to form the description. I mean, what? How to find the image of extended object? That you must show it here. Okay, how it is formed? If you explain, then everything is very clear. So this is the object. Lens you take there only. Then draw the ray diagram. Light ray get diverged, isn't it? And you send another ray through the principal axis, optical center. This ray passes undeviated, produce this in backward, and this A dash B dash is the image now. Clear? These two rays you have to produce back. The ray which passes through optical center, it passes undeviated. So what image expected? It is diminished. It is virtual because you have got it by producing it backward direction. Okay? So U equal to, for this sum, here U equal to and F always negative, concave 21. So use the relation that length 1 by V minus 1 by U equal to 1 by F. Clear? So 1 by V will be what? This will be 42 and minus 2 minus 3. So V going to be what? Minus 42 by 5. Okay? Approximately this is minus 8.4 centimeter. Now what is magnification? M equal to minus V by U. This is going to be, okay. So what will be size of image? Image, or I mean height of image, better to say, H height by H object is equal to M. That is 8.4 by 14. So it is 0.6. So height of image will be what? Okay. Height of object is given 3. So it will be 1 point. It is given 3, no? 3 centimeter. Clear? Check once. What happens if the object moves further away from the lens? Then what will happen? If the object is moved further away from lens, then what will happen? Taking it away from the lens. Size of the image you have to explain. All those positions you have studied. Isn't it? So you do accordingly. If the object moved further away from the lens, the size of image will be more or less. That you have to explain, nothing else. Again, if center is parallel, they will be, it's coming from long distance, they will go this way, it will come, and another one passing through center, it will come, it will be reduced more. Isn't it? All these you will write. Go for next one. What is the focal length of convex lens if focal length of focal length of 30 centimeter in contact with a concave lens of focal length 20 centimeter? It's very easy. Behaving like converging or diverging, it depends on whether focal length you got positive or negative. If it is positive, then converging; negative, then it will be diverging one. Isn't it? So combination formula is in use. 1 by f equal to 1 by f1 plus 1 by f2. If distance also given, then d by f1 f2. Probably we did not derive or we did not work it before. I am telling you today only. No problem. If separation is D, then use this formula and preserve the signs. For concave, it is negative. For convex, positive. Here D equal to 0. So 1 by F will be what? It will be 1 by F1 plus 1 by F2. Simply. F1 is this thing, that is 30 centimeter, and F2 it is 20. Okay, so this implies 1 by F, 60 is the LCM, F is minus 60. If it is minus 60, then their combination will like diverging lengths only, isn't it? Focal length negative means it is diverging. So this time it will behave like a diverging ones. The combination lengths is our diverging lengths. Okay? Clear? Ignore thickness of lenses. If you don't ignore the thickness of lenses, you won't get so fast. It will take time, because there you have to use formula for spherical refracting surfaces. Okay? Let us go for next one. Read the sum. Compound microscope consists of an objective of focal length 20 centimeter. No, 2 centimeter. Eyepiece of focal length 6.25 centimeter separated by distance 15 centimeter. How far from the objective should an object be placed to obtain final image at LDTV at infinity? What is the magnifying power of the microscope in each case? Very, very important question here. And good to clear your doubts yourselves. Okay? So let us start. Compound microscope. For this question, don't use formula, please. You go step by step calculation. Compound microscope. Objective. Short focal length, short aperture. Large focal length, not aperture very large, just large focal length. This one objective lens 2 centimeter, eye lens, and their separation is 15 centimeter. How far from the objective lens should an object be placed in order to obtain final image at LDTV? So just let me draw the rough sketch of image formed by it. Keep it here. Then go by ray diagram. I am not giving in details the ray diagram again. If this is the object AB, you can go through my class note. And this one is LDTV. Okay? This separation is 15. And for normal eye, it cannot be at a distance smaller than that. It will be larger than this. It will be situated here. Okay? So AB is the object, A dash B dash image found by objective, and A double dash B double dash here, which is actually magnified image of AP. Clear? Understood? Now go step by step. Final image is formed here. LDDV. You start from there. This final image is formed by what? This final image is formed by this lens only, which makes the image of this object. This is actually not object. This is also image formed by this convex lens, but this one's action different. This is eyepiece and this is objective. Okay? And this is the action of eyepiece. For eyepiece, A dashed B dashed is the object and A double dash B double dash is the image. So let us use a lens formula for these two cases only. For the eyepiece, what? U equal to, we don't know, but we know V. We know FV 6.25. centimeter. Okay, this F is 6.25 centimeter. Now 1 by V for this lens, 1 by V minus 1 by FV. This U we have to find, isn't it? 1 by equal to 1 by 6.25. This F is positive, this one is negative. V. So minus 1 by U, 6.25. So take LCM of these two. You just, because 6.25 and that 25 will divide that. So how do you add this thing? Will you multiply 6.25? No. So it is better you write this one as 100 by 625. So 25 4, 5 by 25. So U equal to minus 5 centimeter. Okay? U minus 5 means in the diagram, you always keep a diagram ready. This is 5 centimeter. So this 5 centimeter means this one is 10 centimeter. Now go to eyepiece. Go to objective. What do you get in objective? For the objective, U is 10, FO is 2, No, sorry, not U. It is V. Image. It is from there. AB is the object, this is the image. So V10 FO equal to 2. Then solve U. This is U here. We have mentioned its objective length only. So 1 by V minus 1 by U equal to 1 by FO. Isn't it? And this is convex length. Focal length is positive. Just use it. So it is on right side. It is positive. So this will be what? Take the LCM. 10. 1 minus 5. Just calculate. This is going to be 2.5. Okay. Clear? So this was the question. Now your problem is how far from the objective should be final image formed? What is the magnifying power? I have solved the first part. How to get magnifying power? By definition, magnifying power of microscope is the magnification produced by objective multiplied by magnification produced by the eyepiece. So here you go on calculating those two. For eyepiece, M is what? V by U. V known. You take magnitude only. So this is 5. And for objective, you know V, you know U. So here MO, again V by U, that is 4. So MO you got, MA you got. Multiply these two together, magnifying power will come out. So this is 5 by 25. I mean that 5 we already got, so no need to do it again. This is 5 into 4. Answer is 20. Clear? Now what will happen if the image is formed at infinity? Then what? How far from the objective should an object be placed in order to obtain the final image? How you get that? So you will be starting the same manner, the way I did it here. I have taken the final image formed by the eye lens, isn't it? And that way we have calculated. If you say that I will be using the formula, it's up to you how will you use the formula. Okay? But for infinity, magnifying power you don't multiply, please. Why? Because this time in theory, probably I have derived that the magnifying power in this case, in which case? When the image is formed at infinity, M equal to V by U into, remember this. This is the formula for magnifying power if the image is formed at infinity. This VU for the objective. Let me write it. These two are for objectives. You can put it there directly and then check. I am not going to do it because we have just done one part, similar question. It is more easier than that. Okay? Go for next one. This is a very simple, just to remember the topic. What's the topic? Telescope. Telescope for what? Telescope for normal vision. This telescope is for normal vision. Let us do. Objective larger than eyepiece. This is the most important point to consider. Rays coming from infinity will form the image here, which is at the focus of the second lens. Okay. Now final image is formed at infinity. No, not final image, just this is telescope. No, telescope construction is there, objective focal length, eyepiece focal length, everything given, and this is for normal vision. Simple question. For normal vision, AM equal to what? FO by FE. What is FO here? 6. 144. 1 by 24. Okay. Now this is magnifying power. What is the magnifying power? You just simplify it. What is the separation between the objective and the eyepiece? This separation. It's very easy. We have done in theory class also, telling you today. This part is what? FO, and this part is FE. And length between which they are kept, that L is going to be FO plus FE, because it is formed at focus. This part FO, this part FE, so we add these two. This is 144 150 centimeter. Clear? Understood? Now we will solve other sums in another session. Okay? I have showed you. You start, send your doubt.